Hello. Sorry, I didn't realize I was unmuted. Hello, world, or Topl and Co. Good afternoon. Welcome to the our weekly live stream, or at least scheduled live stream. Hopefully, we can get a little more active than just once a week. So, following up on our research AMA from yesterday, we're going to, we want to keep exploring some of the really exciting work that we're doing in the final definition of the Tetra protocol. So we've talked a lot about consensus and kind of some of the big advancements we've made at the consensus layer, and we've really restricted we talked a little bit about what can happen at the asset layer, at the application layer. But one of the big things that we really think will set the Topl protocol apart is our robust definition of very common asset behaviors on chain. So today I'm joined by Christopher Georgian, my fellow co-founder of Topl. Chris and I have known each other for many years, many moons. He is the whole reason I am here today with Topl. After I explicitly asked at some point to let me go because I wasn't doing anything. Chris was like, "You're not taking anything away." So I stuck around, and I think I'm better for it. So. Chris and I have worked pretty long and hard on this asset specification. We've been honestly kicking it around for many years in bits and pieces. So Chris is here today to kind of give us some of the motivation and a broader perspective of why we even care about having a more refined asset model on chain. So Chris, you want to maybe intro yourself to all the live stream.
Yeah, absolutely. Thanks for that, James. I want to start off by saying I am super excited to finally be joining one of these. I found out after it was already happening that our engineering team had just self-organized and said, we're doing really cool shit. We're going to start live streaming. And I just think it's so cool that we've been doing this for, how long have we been doing it for now, James? A couple months, couple weeks?
Yeah, I mean, Sean probably really kind of pushed us probably about 3 months or so.
Very cool. All right. Well, super excited to finally, to be a part of one of these. So yeah, as James said, him and I have known each other for a while. We both kind of got pulled, whatever, into the blockchain space back when he was doing his graduate work. I was finishing up my undergraduate studies, and we've just been dabbling in the space, on and off for years. The first commercial project on the blockchain side for us was very, very different than what Topl is today. We were doing mobile payments, customer engagement, customer loyalty platforms on the Ethereum blockchain. And, I think in a lot of ways we still have the scars of our early days on that project. And then, for about the last 5 or 6 years, I've really been at the intersection of blockchain technology, Web3, and then global development and sustainability, and really just looking at the emergence of all these new markets, whether they're in the global south, whether they are, carbon focus and sustainability focus, as a really awesome entry point for blockchain technology. And really, in just a segment in an area that in a lot of ways epitomizes, the need for trust, the need for coordination, the need for new, very robust market infrastructure. And so we really think those sorts of markets are an ideal jumping off point for blockchain technology. And those use cases really do inspire a lot of our design decisions, because we think if you can design for situations like this or like that, you can pretty much design for anything else.
Yeah, I honestly couldn't have said it better myself. So I guess to kind of kick us off, before I think what I want to do, Chris, is I know we're kind of going on the fly here, so bear with me.
That makes it more fun.
Yeah, exactly. So I think I would like to share my screen and just kind of those first few sections of the draft. So I guess I'll introduce the draft a little bit and talk about what it is, and then maybe if you can just talk about on the first few sections. But I'll take myself off and just throw you up there, and that way it'll just be the screen in there. And if you I don't know if at some point you don't want what's on there, just let me know and I'll pull it off the screen. Cool?
Yeah, that works great.
Okay, so here we go. So today we're going to be going over, or discussing at least, this Topl Asset Management V2 protocol, right? So this is still a working draft. We're still in the midst of finalizing steps for it, but there's some really amazing kind of consequences that have come out of us just really trying to look at what's out there, and like what it means to develop a rigorous like like mathematically based or like protocol based definition of what assets are allowed to do in an on-chain environment, as well as accounting for how on-chain environments need to be flexible enough to allow a myriad of use cases off-chain, right? So that's the balance we're trying to strike with this Topl Asset Management V2 specification. You might also see it called TAM2 is the shortened version of this. So I'm just gonna maybe scroll down a little bit to now this is, again, like I said, this is a work in progress. This is a very long table of contents. It's not all filled out yet, but there's honestly even more to go. So we're gonna spend a little bit of time talking about the kind of at a high level. And then once Chris sets the stage for us, I will go to some diagrams and try to give a more intuitive sense for, because I'm a very simple man. I need pictures. To feel like I understand something, I need to draw a picture. Yeah, so with that, I will remove myself, and then Chris, if you just want to let me know to scroll, or if you want to go down, or just let me know what you want to do, and I'll take care of it.
Yeah, absolutely. So, to start on the side of motivation and kind of on the side of why Topl took this approach as opposed to the approach that I think a lot of other blockchains take, which is just basically to leave it all up to the smart contract designers, to the application designers, and basically say, do whatever you want. And, in a lot of ways, that's kind of a cool approach. It just lets developers discover use cases in their entirety, and it kind of allows a completely blank canvas for people to work on when they are creating assets. There are, though, some, I would say, pretty major deficiencies to that, in the sense that sort of flexibility and that sort of blank canvas is, I think, a lot of times why that you have security vulnerabilities and implementation challenges when you see people trying to do things using smart contract languages on blockchains that maybe could have instead been done at the protocol level. And in a lot of ways, we think of what we're doing as we're taking the burden, we're taking the design challenge and saying, how can we enable some of this functionality at the protocol level so that developing applications, developing use cases on the top of blockchain is that much easier for application developers. It's kind of it's an us or you guys question in terms of who has to take the challenge. And, whenever possible, we think we'd like to take that challenge basically off of your plate, so everyone can just build their applications in as easy and quick and as robust of a way possible. The reason that we think we're able to do that is because as we look around to other token standards, yes, there is kind of that full flexibility that everyone can do whatever they want. But I was, lucky enough or unfortunate enough, depending on how you want to look at it, to be pretty active in the blockchain space during the ICO craze. And despite the fact that people could have written any type of token standard that they wanted, 95% of them used ERC20 tokens. And what that ERC721s, 1155s, whatever they may be, what they tell us is people do group around certain behaviors. They gravitate towards use cases, and that will cover, 80%, 85% of, tokens in circulation. And if you have such huge coverage with kind of these more narrowly defined models, why not put that at the protocol level? Because then if you do put it at the protocol level, you can make it faster, you can make it more efficient, you can make it more secure, you can make it more robust. You just get all those advantages of doing something at the protocol level as opposed to the smart contract level. But then, yeah, as James was saying, that does open up the question of how can we make sure that we're flexible enough? And I think James is going to get into that a little bit later on, in terms of, we think we go well beyond with some pretty exciting benefits beyond that, NFT fungible token distinction, and have a decent amount more in there. And I can see, wow, James is learning how Macs work. I hope so too. Because I don't have a better way to share chats and this thing, James. So if you can scroll down to motivation, I want to just maybe touch on some of the things that we keyed on when we were designing the specification. So really what we did is we focused on 4 different things: composability, interoperability, fitness for purpose or applicability, and extensibility. The first one, composability, I think is in a lot of ways one of the most important things that we're focusing on. And the simple idea of composability is that you're generating tokens in one application and you're able to use, consume, somehow modify them in another. If we really think about what blockchains are good for, blockchains are really great at solving complex coordination problems. But those complex coordination problems oftentimes need multiple applications in order to run. One of my favorite examples that we have a ton of interest in, and we're talking to tons and tons of groups about, is this idea of carbon neutral commodities. So I have some sort of agricultural good, mineral good, something. I have some good moving around the world, and I want to make it carbon neutral. But for that use case, right there off the bat, I have a supply chain application and I have a carbon application. And the supply chain application needs to basically buy carbon from the carbon application and then pair that carbon up with the corn asset, with the coffee asset, with the diamond asset, whatever it may be. And then that's not even touching on the further composability that you would need if you were doing financing on any of these activities. So you need those tokens that are existing because of this system to be able to flow seamlessly and be used seamlessly through, as many different applications built on the Topl blockchain as possible. An extension of the idea of composability is this idea of interoperability. The blockchain ecosystem is, I think, finally proved the fact that we're going to end up living in a multi-chain world and that there's not going to be one chain to rule them all. But at the same time, moving things between different chains is proving to be incredibly important. So even if 2 groups have, different smart contract languages, different token standards, that's fine. Then you just need to make sure that you are able to create, robust mappings between them. And we need much better bridge technology than we have today. And we need much more secure transfer protocols. But in a lot of ways, we think that starts with robust and well-defined tokens so that you can have bridges operate on those well-defined token standards. So, composability and interoperability, I think in a lot of ways are almost 2 sides of the same coin. If we think of one being intra blockchain and we think of the other one as being inter blockchain, these last 2, or the second 2, goals for us really are, I think, connected as well. One is this idea of applicability. So for, those of you who are maybe a bit familiar with Topl, you'll know that we really brand ourselves as the blockchain built for good, or the blockchain built for impact. And we have this very strong focus on sustainability, inclusive development, and everything like that. And so as we were testing and as we're developing this token standard, those really are the use cases that we are first testing against. We're asking questions of, is this standard, does this work for carbon credits? Does this work for trade finance and the tokens that might be coming around because of that? Does this work for agricultural commodities? Does this work for other sorts of impact claims? Like if I want to have the gender equality or the fair labor alternative to carbon credits, does it work for that? And that's what we think of as applicability. We need actual use cases to test against our fun theoretical models to make sure we're not just thinking of crazy ideas that have no connection to the real world, because quite frankly, there's enough of that in the blockchain space without us adding to it further. The other side of that is extensibility. Yeah, cool tech is a lot of fun, but sometimes we got to slow down with that. The other side of applicability is the fact of just extensibility, right? We don't know everything. We don't know all the use cases, both inside of the impact space and outside of the impact space, that the Topl protocol can one day be used for. And we need to make sure that we can extend beyond those initial use cases we test against. And again, I think in a lot of ways, what James is going to highlight in terms of how we go beyond that simple fungible, non-fungible distinction is really key to that extensibility and really key to having built something that is robust enough that we are confident in codifying it in the protocol itself. So those are really the 4 different areas. And then, yeah, as James was saying, this document is really just a high level of all this. And based off of that, people will understand how to implement the token standard, but it'll also be a way that our team internally will be able to make sure that we are implementing this properly on the protocol side as well. So still early days, but I think very exciting progress is being made. So James, are we going to get some Excalidraw at this point in time? You're muted.
Thank you. Yeah, I mean, definitely I will, we're definitely get some Excalidraw in there. But I'm really curious, like, I know you only have a few minutes left with us, but, you know, you spoke a little bit about trying to enable composability with the assets, and also, you know, some of the things that we think might, or we kind of view as deficiencies in other chains, right? That yes, the ability to do anything is amazing, but sometimes you don't want the ability to do anything, because that also means that you can do, you have as many bad, or you have probably more bad paths than you have happy paths, right?
Yeah.
So in general, like one of the approaches we've taken, and actually now that as I go to say this, we should just put this in the rationale, around saying that is better, maybe restricting the set of happy paths, of possible happy paths, trying to do that in this goes to applicability, like trying to do that in a way that is going to cover the biggest set of use cases, right? Like that, that is, we're going to restrict functionality, but we need to make sure we're restricting it in a way that isn't overly restrictive just for the sake of, because then we're going to, like, you know, obviously that means we just can't do more. We can't cover as many use cases. So that is like one balance. But then the other, there's also, so I'm sorry, that was like that's one like major goal in mind is this idea of like 20% of the code, 80% of the functionality, right? Like there are not that many useful design or applications that have worked, that have been demonstrated to work in the blockchain space. Like tokenization in and of itself has been demonstrated to be a very useful primitive, right? Like obviously it's, you know, Bitcoin's entire existence is predicated on just like we can tokenize things.
It's tokenization of one thing.
Exactly, tokenization of one thing. So obviously we're going to support tokenization, but then going beyond that, right? You know, where we are making a concerted decision to not give complete flexibility, but to give a well-defined set of flexibility that we think covers all of the use cases. And like Chris said, like we're specifically targeting or using impact as a framework for us to evaluate against. But I'm really curious, like, you know, one of the, or like, why do you think that that's useful, right? That's the question I want to get, is like, why do you think, what kind of, I guess what I'm trying to get at is, I'm trying to get you to say, like, what kind of use cases could the bareness of these asset models and like these sorts of things enable that you don't think are possible in, or much more difficult to do in like EVM type systems in particular, or less well constrained systems?
Yeah, absolutely. So, I mean, if we think of the concept of bearerness, it's really quite closely related to the concept of composability. And oftentimes people will talk about different blockchain use cases, especially around like trade finance or, you know, cargo ships moving in and out of ports. And there's so much of that entire space that, like, to this day has never been digitized. And quite honestly, until probably about 18 months ago, even I didn't understand why it hadn't been digitized. And whenever anyone would tell me, oh, you know, we should use blockchain for this, or there's so many supply chains originating in the global south or whatever that are going through all these ports, and it's like not digitized at all. And so we need blockchain. And usually what I would have always told them is like digitize first and then use blockchain technology, like, you know, take step one and then take step two. But what I realized only recently is that the reason that certain digitization has been held back is because things weren't able to be bearer. And there's this idea, there's like this special quality that paper has, that in a lot of value chains, in a lot of markets, in a lot of contractual situations, holding the piece of paper is good enough, or is the same as having your name on it. And that's like an amazing concept. And there's so many parts of like our normal daily lives as like consumers, retail, all that stuff that like we don't see any of that. There's huge industrial global trade processes that run on this concept that if you're holding the piece of paper, it's the same as it, being assigned to you. And fundamentally, if we think of, the fully flexible EVM, ERC20, ERC721 model, those tokens like aren't actually bearer because they need more than just the blockchain. They're sitting in like this sub ledger that is the smart contract that can have external controls on it that someone else can like entirely shut off. And if someone else can entirely shut that off, control it, hack it, whatever, the tokens that come out of that aren't bearer. And they have like this extra dependency, this extra vulnerability, and therefore you can't digitize or blockchainify a lot of these huge global trade processes using that. But you can in a model where the tokens move around completely independently and completely detached from anything else. So that's really one of the advantages that you get beyond like all the technical benefits of pushing those things down to the protocol level. You just get that conceptual benefit of tokens are free from smart contracts, and therefore you can do a lot more with them because of that. One thing I want to add though is, as we're thinking of like, oh, because we put this at the protocol level, we constrained it. Yes, but we only constrained a very particular thing. We only constrained the token model. There's still everything in terms of like what we can do with propositions and how you can lock those things up. There's still everything that you can do in terms of your cryptographic commitments. I mean, hell, people are still trying to use Bitcoin sometimes to like put cryptographic commitments. I'll analyze that cryptographic commitment off chain and we'll just kind of go back and forth exchanging cryptographic commitments on the Bitcoin blockchain. You can still we could do things like layer turn complete smart contracts. On top of that, like that tokenization piece that we're putting rules in place isn't everything. It's like the tokenization layer of it, but that layer is only one amongst many layers of functionality that are exposed and that can be used for different use cases.
Yeah, and that's I think that like that bareness is particularly important. I think the thing for I don't know, maybe anyone else is a few years ago I was listening to I think Zero Knowledge podcast, and there was the interview was I don't recall exactly the group, but they talked about how they were digitizing purchase orders and how you would want to digitize a purchase order because just the fact that you have a purchase order means that you can leverage it and like take out loans against that purchase order. So this is apparently a pretty common practice that if someone like Walmart gives a small company or a mid-sized company, right, like a purchase order for 50,000 units, maybe they don't have cash on hand to produce 50,000 units, but they can go get a loan against that purchase order because the backer, the or whatever the term is, right, the bank knows that they have a piece of paper that's going to like they trust Walmart to honor that debt or to honor that purchase order, so they know there will be funds, so they're willing to extend a loan so that the purchase order can actually be met, right? And that was the first time it like clued into me is like, oh, the bearerness of things is in and of itself important. Just the fact that you own something, it doesn't have to be actionable, right? The purchase order itself isn't actionable, right, until the goods actually are produced. Mm-hmm. But the fact that you can have a thing that you can point to and like have make provable arguments of some sort around is an incredibly useful concept. And coupled with the like a robust definition of assets and what it means to have asset behaviors on chain, really kind of opens up a wide swath of like surprisingly to me, like a surprisingly wide swath of use cases where you can replicate a lot of the functionality that has, like I said, has been proven out to be useful in these distributed systems, but without needing to have torn completeness at the single transaction level. Okay, so the last, do you have
yeah, absolutely.
Okay, all right.
So by the way, for anyone, the reason James keeps asking this is because I'm in the Netherlands at the moment, so it's about 11:36 right now.
Yeah, I'm trying to let the poor man go to sleep. I know his fiance is probably just like also like, come on, let's go. So one thing we struggled with for a really long time, I don't know. It's just one of those things that and I know we've talked about if you've seen one of the streams about the assets thing before, you've heard me talk about this, but it's such a weird concept that I have to keep repeating it. And that is like, I want to hear, how do you think, or what do you think is the best way to convince people that because we incorporate it into the spec, but like this modified idea, like why do we think about fungibility in like why do we put so much thought into fungibility? So when we get to the diagrams, you'll see that it's actually kind of hard for me to explain, because the like number of steps to justify like why are you doing this complexity is it's a good question to ask. And this is my attempt to try to motivate that the use cases in themselves are like extremely relevant. And so, yes, this is a reasonably complex structure, but what you get out of it is a robust and well-defined like asset management system that we believe can be very, very useful when coupled with the Quiver smart contract language to allow for very, very expressive smart contracts on system on chain. I mean, so yeah, Chris, to come back, the this idea of the subjectiveness of fungibility, right? Like, how do you think is the best way to express that idea to people?
Fungibility is so much weirder of a concept than the term NFT coupled with a JPEG leads people to believe. I mean, so like a few different examples, I think all get at the idea of fungibility in like different ways, or at least around the idea of fungibility in different ways. The one that I'm guessing James has maybe talked about already is this idea of cash or dollar bills, euro bills, whatever it may be. And if I'm going to the store and someone says, do you have change for a 20 or something like that, I'm considering all of that pretty fungible. I walk in, I've got 20, I walk out, I've got 20. Maybe it's in the same bills, maybe it's different. But if I am, the government or some sort of enforcement agency, each one of those serial numbers makes each bill not fungible with another, because maybe one of these serial numbers went through a drug trade and another one didn't. And therefore, those two bills, you cannot interchange those. They have different pieces of information attached to them. And, the government cares about those pieces of information, and, the consumer doesn't. So that's one way to think about fungibility. The other confusing piece about fungibility is, I think, this idea of fractionalized art, in the sense that, we say there's a piece of art out there, and that piece of art, just like, a Bored Ape JPEG, is non-fungible, right? One piece of art is not freely interchangeable with another piece of art. But if I fractionalize that piece of art, then I've got like this new token, this somehow connected token, and I've got 100 units of that NFT, and each of those individual units is fungible with any of the other units, but they're still all units of an NFT. So how does fungibility play into that? And then the third one is this idea of taking things and turning them into baskets. And so, for example, if we take a bunch of, let's see, we take a bunch of diamonds, and, diamonds are all unique, they're like snowflakes. That's why we love them so much. Each one is special. But if I wanted to invest in diamonds, maybe then I'm just buying and trading units of like 100 carats of diamonds, all of a certain quality and above. So in that case, I started with something that was non-fungible, a diamond, but then I put a bunch of them together, and then I got like this new fungible thing where I'm just like freely swapping it. And really all of that to say is fungibility is complex. Fungibility is, I think much deeper than the binary distinction in terms of, do we have levels of it? How subjective is it? What decisions get made at the protocol level versus what decisions do we want to allow the application developer to make? Because, if I've got a cash app or something like that, or some app, just operating on money, the consumer grade application is going to treat something as fungible that the government grade application is going to treat as non-fungible. So there's some fungibility or non-fungibility at the protocol level, but then maybe we reserve some for application developers to pick and choose on as well. But yeah, it's a much more complicated concept than the simple ERC20 NFT distinction, I think would have people believe.
Right. Only a little bit. Only
Just a
slightly more
smidge.
complicated. Awesome. Yeah, I guess I didn't actually know this, so thank you, Imgrand, that apparently a lender funding a purchase order is called a factor. I did not know that was a thing. Very interesting.
Yeah.
Okay, so I guess before we hop into the spec again and some of the diagrams, and potentially Chris hopping off, I just want to kind of maybe open the floor for any questions and see if anyone, at least with what we've described so far, is there anything anyone's curious about? We should make a little timer up here so that when we ask like, are there questions, we can just hit the timer and then
Like a countdown timer for that.
Yeah, we just stay silent for the entire time. That'd be awesome. That would just be weird pauses in the middle.
I think that's like why they have the Jeopardy music for things like this.
That's true. Yeah. Okay. Well, while we wait for some questions, I will, since we're like right around the halfway point or so, I will probably spend about the next half hour or so going over the pictures. So just for anyone who's new, who just like recently joined the stream, I'll just reintroduce ourselves. So I'm James, the chief CTO at Topl, joined by Christopher Georgian, who is the managing director. And today we're talking about the Topl Asset Management V2 spec, or TAM2 spec, that is currently under development for scheduled implementation. So the specification is under development, and then it is scheduled for implementation within the Tetra protocol, upcoming Tetra protocol. Okay, well, Chris, I'm going to switch over. You happy to, if you have any questions while I'm going through this, feel free to pipe up, or I'll kind of let you play it by ear there. But I think I'll hop back over to the spec. If there are any questions while I'm going through it, please feel free to drop them in the chat, and I will go ahead and answer.
Awesome. This was a lot of fun, James. Thanks for bringing me on.
Yeah, man. Look forward to having you guys on more.
Absolutely. We'll make it a thing. All right. Let's pull up Excalibur on everything else.
All right. Here we go. Okay. So, like Chris said, I'm happy to talk about the motivation a lot, or what we think can be enabled from the scheme that we're going to talk about today. But I, in general, would like to focus more specifically on, how do we actually achieve the things we want to achieve? Please, like I said, remember, this is a work in progress. Let's see if I can actually see when I zoom in, it doesn't, I wish it would word wrap a little bit so I could make it bigger for folks. Why can't you do this for me, Safari? I'm trying to use a new, I know everyone who's knows how to use Macs. They're just what is wrong with you right now? Oh, there we go. That works a little bit. Oh, okay. I should have done this when Chris was gone. My bad. Anyway, so maybe this is a little easier to see. Sorry for all the folks who are native Mac users. But so the registration process, right? The token minting process. I like to think of, or I kind of start off. I'm gonna scroll through a lot of stuff. Just ignore it for now. We're coming back to it. I promise. It is useful to start here. I think. What is the actual? What do the tokens look like on chain? What is the schema for the token on chain, right? And what I would like to really, a token on chain is just these two things, these two fields, and I forgot actually the most important field here, that there is a quantity associated with. So there's these two IDs. I haven't updated these. We've changed these names, but there's a we call it a class ID, and I know it's called instance ID here, but we recently changed this to series ID, as I think it's a little more clear for folks. But they're basically just two IDs that are assigned to a token along with a quantity. And those two IDs allow us to define are the two controls that we provide fungibility definition on. And then the quantity, which, like I said, is not, I don't actually have labeled in here, but it's just a field at the same level as asset instance. The quantity will enforce the type of sum rule that we want to enforce on chain, right? So just remember that the important thing is that there are two IDs and a numeric quantity, and that is basically all an asset is. So I'm going to just, right, in our little Excalibur model, I'm going to just, easily try to denote in the most toy model-y way possible, just the fact that there's a label here on the left and there's a numeric quantity on the right? So we are going to, for the time being, neglect metadata and commit data and other types of data that you might want to associate with a token on chain. This is not where, we haven't gotten to the actual specifications of that right now. I'm trying to define all the behaviors. So that's what I'm going to, at least for this conversation, I want to focus on that. All right. So a box is just, when I say that there are those two IDs, right? There's also an ID at this level, right? So we refer to this as the box ID, right? Or you could similarly call it like it's the box ID is just another, it's synonymous with the UTXO. We derive box IDs from the transaction that generated that UTXO, the ID of that transaction and its index, right, within the outputs, right? So just the normal backwards looking pointer from inputs to outputs, but we just call that UTXO ID a box ID. We just refer to it, we just kind of as a useful metric or useful like atomic data structure, we call UTXOs boxes. So there's a box ID, right, as well as a class ID and an instance ID or a series ID. So there's those three IDs. The way we will denote this is something like class ID dot series ID dot box ID. That's what this structure just beneath this is, right? So here I'm just picking random labels. I'm saying that this asset has a class ID of just A. It has a series ID of A1, and then box IDs are always unique to the protocol, UTXOs. So I'm just going to call it X here, and has a quantity of 5. So there's, just some quantity, some amount associated with it, and we're going to call it 5, right? Whoa, interesting. Okay, so that's how we'll think about assets in this model. Like going forward, we're just going to like these very simple things to motivate why this is a good enough definition for us to start to explore the scheme. We can think of this part on the left as the label, right? It is just the way that this aggregate thing, the A.A1.x, right, is just the label. It is just you might call it like the token label, like right? It's unique to a specific instance on chain, right? A specific token instance or instance of a token, and A and A1, like the class ID and the policy ID, commit to the behaviors of this token in different ways, right? And so that's the next thing that we want to explore or think about is what do these different, like why do I have this complicated like label scheme and this like coupled with this numeric thing. I guess the easiest reason for me to, or like in my mind, to motivate this was the statement that I make about I kind of realized in the previous version of our protocol named Dion. And in Dion, and really in many, like, Bitcoin would also say the same thing, right? But you must enforce, like for transactions to be valid, that the sum of like inputs has to equal the sum of like outputs, right? So that's to say that it's a zero-sum rule. You're not allowed to create tokens out of nothing. So like in Bitcoin, all of your Bitcoin on the inputs has to be accounted for on your outputs, minus the fee, right? Because the fee, that part isn't in the transaction itself. It goes to the block producer. But we can, in a system where we allow native assets, or we allow for multiple types of assets in a single transaction, we can't just say like the sum of the inputs equals the sum of the outputs. We have to say sum of like inputs equals sum of like outputs, right? And once we kind of understand this phrase, then we can break it down. We can notice that there's a sum. So there's three parts to this left thing over here, and there's equivalently three parts to the right thing over here. So the first one is inputs and outputs, right? And inputs and outputs just refers to the position of the UTXO in the transaction. Is it being consumed or is it being created? So consumed is an input, created is an output, right? So it's just on which side of the transaction is it? Which side of the transaction on changes what you need in order to have a valid transaction, right? If it's on the input side, you have to provide a proposition and a proof in order to satisfy the spending logic and therefore consume that input. And if it's on the output side, you have to assign it an address and any corresponding metadata or other associated data that you want on the output token, right? But just to say that, again, there are a few things that you kind of implicitly tie down whenever you say something's on the input side or the output side, right? In a similar fashion, we have a numeric part to this statement, which is sum equals sum, right? So the numeric value of the left side has to equal the numeric value. The numeric value of the input side has to equal the numeric value of the output side, right? Now that kind of intuitively makes sense. This is indeed called a zero-sum rule. So I mean, maybe it's equal sums would be a better way to call it, but I think this is maybe I have this rule name wrong. I'm calling zero-sum, whatever, because you're not making things. Anyway, the important bit is not my rambling, but the like part, right? Maybe that's why I saved it for last. It is the most important part of this little scheme that we're gonna keep going through. So when I say sum of like inputs equals sum of like outputs, what does it mean for two things to be like? Right? So in the Dion protocol, where we also allow for native asset creation, we have this thing called an asset code. And an asset code is generated by a secret key. It's tied to a secret key. Therefore, there's only the issuer, the original issuer of an asset is allowed to continue to issue that asset. But that single asset code, that single identifier, is what the protocol uses to enforce that, to say that two boxes are the same or not, right? Because it just looks at the asset code. Or similarly, you might say, we could say that in Ethereum, the way they do this, in an ERC20, every token that's within a certain contract, within the ledger state of a certain ERC20 contract, right? They're all fungible within that, right? They're all, we say everything within that one ID is right? Because they're all tokens managed by the same contract, okay? So, and lastly, and most importantly, refers to labels, right? So this is how I motivate that this is enough for us to think about, this description is enough for us to continue to think about the asset model, right? Because that statement, sum of like inputs equals sum of like outputs, input output, that part is defined, is by definition in the transaction, so kind of outside the scope of this thing. But then I have the numeric part and the label part of that statement. So here's the numeric, or the a.a1.x are the labels, or how we construct the labels, how we identify whether two things are like or not. Or in other words, how we substitute whether two things are allowed to be substituted or not, right? That is what fungibility is. It is whether you can distinguish between two things, or you can substitute two things, or whether two labels are the same, right? And then the quantity, right? We have that numeric part. So we have to define so there's a quantity that holds around. Okay, so like Chris said, we want to be able to define a set. I'll tell you, we've been working on this for quite a while, like having discussions around it for a very long time. And what I'm going to show now, these 4 layers, are useful in their construction, but they are. I do believe there should be questions. Like, I don't think that it is. It does take a little bit of getting used to, as I explain it, to like really see why this could be useful. And so I think the examples mostly motivated are like when you see the examples, it kind of like clicks. So I'm happy if it doesn't make sense, please ask questions, right? I really want to make sure that this is as being introduced and described in as useful a way as possible. And so that's why we're kind of going through this whole exercise. Okay, so the first thing we're going to ignore. So here we decided there are these 2 labels, right? There are these two fields. There's the label part, or the fungibility control, and the quantity part, or the numeric control, right? And I think this little table right here kind of best describes what these 4 fields that I'm about to describe, that we then create a truth table out of. And from the truth table, we derive some behaviors. And then we are going to, if we have a little bit of time, we'll describe what those behaviors mean. But so on the fungibility control, the first label that we want to fill is this question of inter-series fungibility. So, I realize I never showed you the actual construction. I apologize. Oh, crud. I don't have it on this machine. I guess I'm just going to jump down to this really. I need a good example. Here, let's just maybe do this, right? So here, maybe ignore all this other stuff. I just want to point out that so A here is I'm gonna refer to as my class ID. B, the middle one here in the second position, I'm going to refer to as the series ID, and the second one is the box ID, right? So in this top thing, I'm saying that both of these boxes share a class and share a series, right? That's what both of these things having a 1 in them mean, right? Whereas the second row, this row, they share a class ID, but they do not share the series ID, right? And in the third one, they share neither a class ID nor a series ID, right? And by definition, within the entire protocol, we are going to say, you can never share just a series ID, right? We're just going to make that a definition, and we enforce it by the construction of how you actually create tokens, right? So tokens in the system will be created relying on the DAG nature of the underlying transaction graph, right? And this will help with validation to enforce supply controls and so on and so forth. But that's a little more complicated stuff. So for now, I just want to think about labels, and we want to think about the behavior of having 2 levels of fungibility. We have class, and underneath classes we have instances. So this is why I'm a little upset with myself. I had a nice little diagram showing this nesting. So I apologize that I didn't get that, or didn't have that prepared. But right, if you have a class, and a class can have a single series, right? There can be a.a1 and that's it. Or a class can have multiple series, right? You can have a.a1 and a.a2 and a.a3. And we always, and not always, but there can also be a multiplicity underneath each series, right? So there can be an a.a1 and an a.a1y, or I'm sorry, an a.a1x and a.a1.y. So very good question. Are series and class the same thing? So series and class are not the same thing. They are it comes down to these questions right here at the top. Inter-series fungibility versus intra-series fungibility. So series are housed underneath a class, right? So if I have inter-series fungibility, it means that the protocol will consider assets like if they share a class ID, right? That means that all it takes is for like a.a1.x, and a transaction. Let me zoom out just a touch. Oy, what happened? Come back. One more time. Here, you know what? Dang, what is not helping me, man? Okay, whatever. We're just gonna. So this transaction a.a1 x with 5 and a.a2.y with 10 here. Those on the left side, we're saying those are the inputs, and on the right side, we're saying that that's the output, right? So this output is, we're going to say can the result of the on-chain transaction be a.a1 or a2.z of 15, right? And the important part here is that basically the protocol is going to ignore that A1 and A2 are different, right? So when you have inter-series fungibility, the protocol only looks to enforce that a class ID is shared between tokens. And it says, and within the transaction, all tokens that share a class ID will be considered fungible, or will be considered substitutable for one another, right? Will be considered like, okay? On intra-series fungibility, that is within a series. So that's at the box level, right? So remember I said that it's like a domino thing, or it's a nested thing. So you have classes at the outer level. You have series one level inside, and so there can be one or many series within a class. And again, you can have one or many boxes or tokens in a series in a class, right? So it is like a map of maps, right? So it's just you have some key and a value, right? But I can have in the second layer, I can have multiple keys, so I can have multiple values, right? But overall, yeah. So I think that the like nested map structure is to me, the easiest way to think about it. But at a protocol, like how do the transactions deal with it kind of thing, intra-series fungibility means that to consider two tokens to be like, they not only have to share A, they also have to share the second level, like A1, right? So if a token only had intra-series fungibility and not inter-series fungibility, then if it only had intra and not inter, then A.A1 would not be the same as A.A2, right? So when you only have intra, then you have to say A.A1 will equal A.A1, right? And then when you have inter, then you can say A.anything equals A.anything, right? Okay, so if we just, I will posit, I will agree that that's a bit of a weird thing to do, right? But let's just take those rules for a second and see how do they apply. If we just define that these are the rules, let's go through and see what different combinations of the rules will be. And I'll do this last part, and then we'll break for the day, even though there is a little bit more we could go through. I don't want to keep people too much longer. So like I said, let's just focus on these first two. So false and true. So I have inter-series fungibility, but I lack intra-series fungibility, right? I apologize. I lack inter-series. I have intra. So this means that A.A1.x of any quantity m would be equivalent to A.A1.y of any quantity n, right? and you can really ignore the M and N. I know I put emphasis on them, but labels are what we care about right here. So it's A.A1.anything. It would be equivalent to A.A1.anything, right? But when I don't have inter and I do have intra, then A.A1.anything, this should not be an X because you can't, I forgot to go like clean these things up. A.A1.anything would not be equivalent to A.A2.anything, right? Because when I don't have inter-series fungibility, I only have intra, so I cannot switch the second label, the label in the second position. What do we call this? I think it was like W, Q. I'm being pedantic here because box ID should never be replicated, so I'm trying to make my my figures accurate. Okay, so we've covered these first two, right? This one says if the first label, because I have intra, that means the second label has to be valid. Because I don't have inter, I can't, or the second label has to match. Because I don't have inter, then if the second label doesn't match, it's not equal. And then by definition, we just enforce this across, at least at the default chain behavior will be that no class at the top level, there's not a behavior on a default behavior on chain to say that an A.anything could ever equal or ever be considered like with a B.anything, right? That is to say, on chain, classes are always distinct from one another, right? So within a class, user or dApp developers have the ability to define fungibility within a class, as well as to define some more control at the actual box level, right? But between classes, we just define that the default behavior on chain is that you cannot consider two classes to be fungible between one another. I'm leaving myself a little bit of an out there because there is a case where we can support that. It does require more information from the off-chain application, but it does give much more freedom to the application to move data and manipulate data on chain in a way that suits the application. What we're going through at this moment is just the default behavior that will cover many use cases. But again, that whole balance of trying to provide flexibility and a rigorous set of good, secure, safe defaults. Yeah, last thing we'll cover is this case that is covered in red here, right? So technically we could, so I have, right over here, I have we have the three, technically it's four, it's, because I have two Booleans, right? So I could have the four different combinations. I could have true, false, true, true, false, true, false, false, right? I know I did those in a weird order, but one of the cases we define, because of the DAG nature of how we create the tokens, series IDs can never be replicated, right? And for now, I think we need to take that as a given, right? I can explain, or like I said, to explain, to motivate how that comes to be is it's a little involved. It's those chicken scratch diagrams that I showed that I scrolled past a second ago. But the whoops, oh my goodness, I didn't know the three fingers did that. That was Mac. What are you doing, man? I am learning. Why can't everyone does Apple have a patent on this thing? It's so useful, and no one else seems to be. I still like my nub though. I'm sorry. I like the, track point for life. Anyway, sorry. Because series IDs can't be replicated on chain, it doesn't, this particular situation where you say I want inter-series fungibility, but I don't want intra-series fungibility, right? That would result in a case where you want A.A1 to not equal, or A.A1.x to not equal A.A1.y, but you do want A.A1.x to equal A.A2.y. right? And that's a little bit of a weird thing because we want to, because I said there's like a relationship between classes and series, right? Series are in classes. So if I enforce that there's, I want to be able to determine fungibility, or like I have inter-series fungibility, then I can't, that like implicitly means that you also provide, or we are also providing inter-series fungibility, right? I'm sorry, if I want to provide inter-series, I'm implicitly saying I also want intra. I apologize, I mixed that up. So basically that this is a case that we are going to say is invalid, and we're not going to put on chain, or like we're not going to support on chain. We would have rules against it, just that because it is a bit weird in the structure of it. I'm happy to motivate that more if people have other questions, though. So the different combinations that are actually valid are false true, true true, and false false, right? And in the false true case, these are the things that you want to enable, right? You want to say that a.a1.x is equal to a.a1.y, but a.a1.x, oh man, I forgot the labels. Pretend like I didn't replicate X and Y and Z and all these things. They're different labels. I will get better about it. Okay, but while we want a.a1.x to equal a.a1.y, we don't want a.a1.x to equal a.a2.y, right? And then again, we always have the, like, by definition one, the a dot anything can't equal b dot anything, right? That's in the case of false true, right? And this is specifically the label, like how the labels work with one another. Okay, in the case of true true, I have inter-series fungibility and intra-series fungibility. Then any token of this class is fungible with any other token in the class, right? All it looks for is the first element of the ID, right? So in this case, a.a1.y, I'm sorry, a.a1.x would equal a.a1.y, and a.a1.x would equal a.a2.y, right? And again, we always have these fundamental that a.a1.x or a.anything cannot equal b.anything. Okay? And now time to break it, right? In the false-false case, I do not want inter-series fungibility or intra-series fungibility, right? So in general, that would mean that the protocol doesn't have a way to enforce fungibility, right? We would not be, we could default and say, when you don't provide intra-series fungibility, this is the same as if you had true, right? We could just default to that behavior. Or we could just say that they're all unique, right? But instead, I think we can cover those use cases in another way. And by allowing for false-false in the fungibility definition, we can make it where if fungibility is undefined, it has to be provided by the application, right, in the transaction. So basically, a transaction will, at execution time, say, here is the asset ID an asset ID that's in this transaction. So say a.a1.x. Here is another asset ID or list of asset IDs that I want this transaction, the current transaction, to consider as fungible with this like first one, right? So you're basically just saying at a transaction level, you give the ability to provide a definition for fungibility, right? And if you do that, then you can actually break. If I provide a definition that says a.anything is equal to b.anything, well then you could. That's how you can break that fungibility. But that is also the most like generic thing that gives all the power to the application, and it means it's the most. It requires the most data and like knowledge of the chain and the state and all that stuff from the application side. But it also provides the greatest amount of flexibility for off-chain developers to be able to modify the state of assets on chain. And if you need more in a trusted fashion, I won't dispute that, right? If you need a more trustless thing, if you want to make a more well-determined and trustless DApp, that is what this set of tokens is, right? These out of these two, with these other two Booleans, so there's technically 8 types of tokens that can come out of this. 4 of which are immediately useful. We could cover. It's like just over here a little bit. The other 4 are maybe useful. They're like strictly increasing, strictly decreasing. Maybe they're useful for counters, yet to be determined. But for the most part, a lot of the functionality comes from just being able to determine these labels on chain and what can be considered like what can be considered substitutable or distinguishable or not. Okay, so I didn't get quite as far as I wanted to. There's a whole nother part of that plot that I didn't get to, as well as, we still have the registration process to go through, how you actually make the tokens. We have the schemas we can go through. And then finally we could wrap up with some examples. So that sounds like three more streams to me, at least. In I guess closing minutes, I'd be happy to take any questions. I know that was maybe it was a lot. So, but like I said, I'm happy to. Let's see. Nice. Alrighty. Yeah, check us out, topl.co. Nice, I like it. Well, I don't have as great or as well narrated a outro script as Sean does, but I do really appreciate everyone's time this afternoon or this evening, and your interest in coming to listen to the TAM2 model that we're working on at Topl. If you didn't have any questions today or couldn't think of anything while we're in the stream, if it does come up, feel free to reach out, and we'd love to engage and happy to explain and go into any more detail. And if there are any questions, or if there are any if you see any problems or something on that sort, if there something you think we're overlooking, I'm more than happy to take some criticism as well. With that, I think I'm ready to get out of here. I'm gonna go enjoy my last day of being 32 and get to a comedy club. So I hope everyone has a good evening. And I don't actually know. My bad. I'm gonna talk to the helpers. I don't know how to throw up the end banner. My bad. Oh, look at that. Thank you. So yes, if you are interested, if you want to reach out engage with us, please, happy to you can find us on Twitter, Instagram, GitHub, LinkedIn, as well as Discord. Please come chat with us in our Discord. Obviously, if you're not on Twitch TV right now watching this, what's wrong with you? Come hang out with us on Twitch. We'd love to have you as part of our community. Happy to please go visit topl.co, learn more about us. And if anything we've talked about catches your fancy and you want to, interested in working with us, we are hiring for some positions at angel.co. Otherwise, I think that's it from my side. And I hope everyone has a good evening, and we will catch you on the flip side. Bye, everyone.